Hi, everyone. I'm James Taylor. I work at Studica. Unfortunately, I don't speak French, so I have to do it in English. Michael Batista is one of our salesmen. He can translate in the chat if anyone needs translating. So today we're going to go over some programming for FTC. If you're coming from FRC at all, you'll find that the programming is really easy for FTC. And you have three different types of programming that you're allowed. There is a blocks programming, which is like Scratch. Then there is on-bot Java. And then you can use Android Studio, which is the most advanced form of programming and allows you to do anything with the controller. I'll go over briefly what the blocks and on-bot Java looks like. And then I will switch over to Android Studio where I'll show everything for today. So let's first share screen. So first things first is at the way First distributes everything for FTC is through this GitHub page. I'll post the link in the chat here so everyone can go have a look at it. On this GitHub page, you will find the latest releases for everything. For the APK to go onto the phone, or the APK to go onto the control hub or phone, depending on what you're using. It's generally not a good idea to directly clone from the main repo, but to actually go to the releases page here. So if I click on that, you can see the latest release, which is version 7.0, which is what we're using for this year. There will be minor updates throughout the year, and they'll always be marked latest. At the bottom, you can see the different APKs for everything. So the driver station is what goes onto your phone, and the robot controller is what goes onto the robot controller. If you use the Rev hardware client for updating your control hub, which is here, it will automatically download these APKs and put it onto the phone for you. If we're doing Android Studio, you need to download the source code and then import that into your Android Studio. We'll go over that later. As for programming, you can see here in the wiki tab, there's a whole bunch of information on how to use the wiki and how to go over everything. Let's show you choosing a programming tool. Here they explain to you what each programming tool is, the benefits behind it, and why you choose each. First off is the blocks tool. This is completely browser based. So when you connect to the control hub over its Wi-Fi, you will then be able to program it via the blocks. And what's nice is it also shows you the Java code on the right, so that if you have a team that's not used to programming Java, they can then see how it all interacts with each other on the right-hand side of the window. The blocks programming is more for elementary kids, as you know, FTC starts in grade 7, so they're not that experienced with the text-based languages. Then there's on-bot Java, which is exactly like Java, except you're programming it in the browser in the same spot that you program the blocks. So what's nice is if you start in the blocks, you can then copy your code over to Java and start modifying it there and then deploy it to the robot. Then the last one is Android Studio, which is the more advanced one, which is similar to how you'd program in FRC using VS Code. But this time we're actually using Android Studio to create the app to send to the control hub. What's nice about Android Studio is it allows you to do more options, such as adding more advanced packages to your controller to allow your robot to do more than what can be done in blocks or on-bot Java. Here you can see the 3 different methods, and it goes on. There's another useful tool for programming and FTC in general, and that is the GM0 website. I will add that to the chat so you can view it. This is considered almost like the holy grail of FTC. It contains a whole bunch of information that's great for any FTC team, such as getting started, learning the hardware, different robot designs, different types of designs inside the robot, such as if you wanted to build an elevator or different transmissions, how you do arms, intakes, everything. It's got it. You can see here in the list, if you wanted to learn about drivetrains, you can learn about different types of drivetrains. If you wanted to learn about how different connectors go together, they have that here. And then we'll have a quick look at the software section. In the software section, they split it up even more. So if we look at the fundamental concepts of programming, here they go through and show you with some examples of how everything goes together. If we, they also
James,
yeah.
There's a question in the chat here.
If we want to implement computer vision or we need Android Studio. So for this year, they modified the APK that you could use OpenCV with onBot Java. However, there are some steps that you need to go through. For learning teams, like if you're just starting out, they have TensorFlow, which first creates a full, already pre-made solution for you. However, a lot of more expert teams use the OpenCV as it's more advanced than using TensorFlow. I will show you in here how they go over the different visions as well. I'll also show you how we added OpenCV to our triangle robot that we use in the videos that we use for FTC. So Android Studio, this goes over how to install it, how to set everything up, add it to the library to where you're ready to program and go. If we wanted to look at the vision, for example, there's a computer vision tab here in the software section. Here, this goes over the TensorFlow, the Vuforia, which are the two built-in applications for onBot Java and blocks. And first provides the solutions for this, which are normally ready to go. You just need to combine it with your code. I'll go over how to use Easy OpenCV, which allows you to run OpenCV on your robot. And new this year, because they opened it up, that you can add extra packages to the onBot and blocks. You can actually use Easy OpenCV in that. However, it's a little bit harder to do. All right, so let's show. Here we have Android Studio. I already installed it. But we're going to actually open the FTC robot controller download. So if we downloaded the release package here as the source code, it comes up as a zip file like this, and you want to extract it. And then it's a folder with all the code in it. Do not modify anything outside of Android Studio. So what we're going to do is we're just going to hit open. We're going to then find where we put that project. In my case, it's here. PC. Did it find it? No. Sorry, I didn't find the project. So when you open the project, what will happen it will open this FTC robot controller folder, which is the folder that we just unzipped. Inside the folder, there's 3 subfolders. So you'll find FTC robot controller. in this folder, there will be examples of different source codes, running vision, anything you want it to do. If I expand here, you can see, oh, did you want to run a basic op mode? Did you want to learn how to use a servo or how to import the IMU that's located inside the control hub? So if I open this sensor BN0555 IMU, you can then see that it contains example code on how to use that internal sensor. There's a lot here because it generally has everything it can do. So you only need to use little snippets of it that you need for your own usage. Where you actually write your code is inside this team code folder. And there'll be another Java folder here, and you'll find code in here. This is where you write your code in this org first inspires Ftc team code. The reason it's here is you want, when you write the code, when you compile it and send it to the control hub, that it will then show up on your driver station phone for you to use. So I turn my control hub on now. It'll take a few seconds to boot. But when it boots up, you'll see that the Pixel 5 here will change to the Rev control hub. That shows that you have a good connection. When you first open this, you might have to run a Gradle Sync. On the right-hand side, you'll see there's an elephant-looking logo. Anytime you add something to your code or a different package upgrade, you always have to run a sync with Gradle. Normally it's pretty fast, so there shouldn't be any issues. You'll see at the bottom right here, it's running a build just to make sure that everything's synced up and good to go. If we look at the build process, you can see that it's starting to just grab everything and make sure everything's correct. You also see this window that pops up here. If using Android Studio, it is very important not to upgrade your Gradle. You must use the one that comes with the project, as everything's linked up and set correctly for that specific Gradle. If you upgrade, what happens is some things become deprecated and the pipelines no longer work. So I'm going to show you guys how we are going to just write simple code for an op mode. First thing off is to create a new full file. So you right click on the main folder, new Java class. You can also create different classes. However, you'd have to do more work to get those classes to work correctly with Android Studio. So if I open a new Java class, it first asks you to give it a name. We'll give it a name as example code. As you see, it automatically creates the package and then the class name. For Ftc, you can go to the examples here and get examples of what basic classes look like. I'll show you here what the two classes look like. There are two types of classes. There's an iterative class and then there's a linear class. An iterative class is much like what you would see in FRC, where it's staged as here's your init loop, your starting loop, and your disabled loop. You can see here we have an init function. So this runs once when your driver station hits init on the driver station phone. Then the init loop will run until the user presses play. When they hit play, then everything runs in this start loop and then loops here afterwards. When you hit the stop button, it then calls this stop function. What's nice about the iterative op mode is that it allows you to put certain sections of code in certain areas of where you need it. So if I want my arms on my robot to initialize to a certain position, that would happen when I hit init. If I wanted my robot to do something special, when I hit stop to make sure for safety reasons, I could put it in the stop function. If we look at the linear op mode, if you notice the difference here, this extends linear op mode, where the iterative one just extends op mode. This is the same for Android Studio, onboard Java, and blocks. They'll both have these two types of op modes. In linear op mode, it is essentially one giant while loop, where you have this run op mode, and inside of it, you have your initialization code, and then you can see a while loop that just runs forever until you hit the stop button. Some teams prefer this way of programming it, where more advanced programming is done in the iterative, as you have more control over what you can do. So in this case, we're going to copy the iterative op mode so that we can move forward. So in the example class, we're just going to type extends op mode. And you'll notice that there's IntelliSense here, which allows us to add stuff when needed. Now, you'll notice right away we get our underlined red code. This is because we are missing different methods that are required for the iterative mode. When you look at the iterative mode, how you have init, loop, start, stop, and loop, and the stop, those are required for the actual op mode to run correctly. So let's add those. So that's the init loop. Now we need the stop loop, we'll add that. Then we need the main loop. And you'll notice now that we have the four main loops here, that is no longer underlined and we are easy to use, ready to go. We can start filling in code. I can't. Zoom currently blocking something. All right. Now what we want to do first before moving on and creating more code is this green hammer up here in the top left, we're going to hit it and it's going to build the code, as we want to make sure everything's working.
James, there's a question.
So when you hit stop, it actually, you have to hit init again to restart it. I'll show this on the phone when we get to it. So here I have the driver station phone and I can demonstrate how it works. So essentially what happens is if you hit stop on the driver station, it will then require you to hit init again before you can go to the init loop. Okay. For this example, I'm going to show you how to move a servo for moving the carousel around in the challenge today. So if we look here, we have the init loop, stop, and loop. What we first need to define is our actual servo. Let me just pull up that code. So what we require first is to create the servo object. So here we'll create the object, private CR. So you notice with the IntelliSense, it opens up and allows us to see. I'm looking for a continuous.
Another question in the chat.
Yeah. We'll open that up and we'll just define it. What's the loop frequency? 50 Hertz. The loop frequency is it's variable. I think they aim for a 20 Hertz and yeah, a 50 Hertz loop, but sometimes it gets slower and sometimes you can actually get it to run a lot faster. Essentially, the loop runs as fast as it'll allow your code to run. It's not like the RoboRio in FRC where it runs at a set clock rate. Here, it's variable depending on how fast you can actually execute your code. Some teams manage to get their loop rate down to 5 milliseconds, which is ridiculously fast. So going on with the carousel motor, what we want to do is inside our init loop, we want to actually create the instance of the motor. So in this case, we'll go carousel motor is equal to hardware map. I'll explain this after. Get cr servo.class, and the name is carousel. So to explain this a bit, the hardware map is when you define your hardware map on your driver station phone of all your motors and sensors plugged into the control hub. What the hardware map does is it allows you to say that this servo motor is attached to the hardware map where I define the device with the name carousel. And that ties everything together, that when I tell carousel motor to move, it will move the servo motor whenever I tell it to do that. We're not going to run anything inside the init loop or the stop loop, but we are going to run stuff inside the main loop. In this case, what we're going to do is I'm going to use my PS4 controller here, that when I push one of the buttons, it will spin the motor correctly. So in this case, we can do a little if statement. So if gamepad. So if you notice, there is gamepad 1 and gamepad 2. That is because in FTC, you can have up to 2 controllers attached to the driver station phone at any point in time. And to differentiate between the 2 gamepads, you have gamepad 1 and gamepad 2. In this case, I'm going to use gamepad 1, and I'm going to use the A button on the controller. So I'm just going to do that. So if gamepad 1A is pressed, so true, it will call this if statement. And in this case, I want to carousel dot set power. I'm going to set the power as 1. So full speed. Now, if I wanted my carousel motor to spin the other way, I could add an else statement. Let's say the B button. So what happens here is that if I press the A button, the motor will spin full speed in one direction. If I press the B button, it will spin full speed in the other direction. However, if it's like this, the motor will never stop. So what I need to actually add an else condition here at the end where I tell the motor to stop so that if I'm not pressing one of these buttons, it does nothing. Now we're going to build the code again to make sure everything's correct. It should be faster to do now, seeing as we're not building a whole new code base. As you can see, it finished in 3 seconds. Now we want to send this code to the control hub. So what we're going to do is, with our team code project selected and the Rev Robotics Control Hub showing up as our device target, we're going to hit play, this run here at the top. So when I hit run, you'll see it'll actually run a build first, and then it will take that build and send it to the control hub. This can take some time. Because what it's actually doing is it's sending the whole APK that we've built to the control hub, and it's rebuilding it on the phone that's inside the control hub. As you can see, there's a launch succeeded here. Now I'm going to just stop sharing for a second so I can show you the phone. So on the phone, you can see it's nice and green, it's connected. I have to hit X in the options button. You'll hear a vibrate. That'll show now that my gamepad's connected as user 1. I'm going to go to the drop-down menu. Oh, I have to change my profile here. Sorry, I said to change over to the correct control configuration. That restarts the robot, and then it will pop back up on the phone. I'm going to select the right-hand side to find the right op mode, which I found. And then what you're going to do is when you hit init, it runs that init loop code. And if I hit stop, then it runs the stop code, and it just brings it back to the init stage. If I hit play, the robot's now live and can move. So if I bring up the robot here, you can see the carousel motor right here. If I hold the button, it will now spin the full speed. So there is a question, is the driver hub working the same way as the phone? Yes, the driver hub is exactly like a phone. It's just made that it's a bigger screen to allow for you to see more data on the phone, as long with they took all the extra stuff that shouldn't be on the phone out. So it's just running what's required for FTC. So there's no difference between the driver hub or the phone. So now to share my screen again. So that's a simple way to get this code to run. What we need to do, I forgot to add here. So right now you can see this code's blacked out. What we need to do is add the @teleop thing here. I'm just going to copy it, makes it easier. Let me take this. The name that you put here is what shows up on the driver station phone when you choose what code you want to run. So if I had multiple different teleops to choose from that I created, so you can see here in my project, I have different types of ops, autos. This is all defined by this example code here. So when I hit the drop-down menu, I will see all these classes, but I want to choose the one that I want it to run. Now, someone asked about the vision. So I'll show you how the vision works. If we go back to the computer vision here, you can see there's the TensorFlow, Vuforia, or the OpenCV. Someone asked the Tetrix Tornado. I'll show that right after this. So for easy OpenCV, you can learn more about it by clicking on here. It'll bring you to their page where they show you how to add it to your project. In this case, adding easy OpenCV is very simple. It's done, before it used to be hard, where now it's easier. It's inside the Gradle scripts. You can add the easy OpenCV dependencies and its Maven URL. And then you just run a Gradle Sync and you have OpenCV in your code. Then that allows you to create barcode, well, pipelines such as this. So here's a barcode pipeline that we made for this year. This will look at the 3 barcode areas on the court and then tell you which position the duck is in. As you can see, 1, 2, 3, or none. What it does is it looks for the area and it calculates and looks at what the main color average is. And if it's in that color average, we know where the duck is, that it's yellow compared to a blue or gray backer. So this is just simple OpenCV. There's nothing hard about it. And it's very easy to learn for the average user. And then inside the code here, we can see the pipeline added with the camera. And then it just tells you in the loop what barcode is where. If I scroll down here, you can see, here's an example. We created 3 squares that go over the barcode areas. The duck is currently in position 1, so it spits out that it's in position 1. If it was in 2, we're in 2. And if it's in 3, it's in 3. So someone asked about configuring the Tetrix Tornado motor with the controller. What you would do is, here I can show you. I'm just going to stop sharing my screen so you can see a bit better on the screen. So inside your phone, you click on the 3 dots, go to Configure Robot. Inside one of your configurations, you're going to hit Edit. If you don't have a configuration, just click Create New. You'll then find the Control Hub portal. Click on that. Click on the Control Hub. Then you want to click on Motors. And you'll see there's motor ports 0, 1, 2, 3. So depending on which port you plug your Tornado into on the Control Hub. So for example, if I plugged into port 1, I'd look at port 1. I'd click on the drop-down menu here, which allows you to choose which motor you want. You're going to search for Tetrix motor and then put a name for the motor underneath it. So in this case, I called it back motor. Hit done, done again, done. And eventually you're going to hit save. Okay. And now your Tetrix Tornado motor is added to your phone and Control Hub. So it's actually stored on the Control Hub itself. So just like in Android Studio, how we define the CR servo, in this case, we're going to do private DC motor, Tetrix motor. And when you define it, you'll go Tetrix motor equals so if you notice Tetrix motor back motor. And then if you wanted to spin this motor, you do it exactly the same way that it's done here with the servo motor. So you'd call text-rich motor dot set power 1, and that'll spin the motor at 100% speed in one direction. Very easy to do. Then with the driver hub and the phone, sometimes it's not an easy way to actually see how your code's looking or print out data to the phone. So with the FTC community, they created a whole bunch of extra packages for you to look at. And there's something called the Ftc Dashboard. You add it exactly the same way to your Android Studio code in the build dependencies. And what this allows you to do is when you connect to the phone, or to the dashboard through the control hub, you type in this IP address. So normally you would type in this to just get to the FTC dashboard. But when you add the dash to it, it adds the actual dashboard to it. And here you can see your camera output. You can choose what op mode you want it to use. You can look at different telemetries on a graph. So if you're calibrating PID or wanted to see different information, they would actually display a graph here with data that you can view real time. You see here, you can print out statements too here, such as the barcode. So if we look here, we're printing out this information instead of to the bottom of the phone here where it can be hard to see. It's now very easy to see here on the computer. If you wanted to add calibration stuff, you can add it in this configuration tab. And it's just extra stuff that you can do with Android Studio that's not possible with bot, Java, and blocks. I'll post the link for this whole project if you guys wanted to view. This is the project that we created for our triangle robot that you can see on our YouTube page that drives around and does everything. And it explains instructions on how to download the code, add it to your Android Studio, how to add the OpenCV, the NavX code if you're using a NavX for your gyroscope, how to modify the code, driving around the robot. And then when you want to do autonomous code, it shows you the OpenCV, had the 3 barcodes on it, how to calibrate the pipeline. One thing to note here is every camera is different, also depending on where you put it on the robot. So you can actually calibrate where these squares go in the camera view just by changing the values here. Very simple. We're starting to run out of time, so I'll open the floor if anyone has any questions, and I can show you how it's done. So the TensorFlow is used for object detection. Some people use it for localization as it offers the. So with TensorFlow, they offer the game images that are around the court that you can use for localization if you wanted to. Not a lot of teams use that because they use something called Roadrunner, which is to put the robot anywhere on the field. For Roadrunner, you could find it in that GM0 software. Let me show you again. So here you can see odometry. This is the main localization, which shows you how everything runs with poses and everything. But most people use Roadrunner. And at the bottom here, you can see Learn Roadrunner. It has its own page that you can go to. And in here, you can see a robot that's actually driving around. This is all done using encoders on the robot, not the actual camera. I'll just post this in the link chat so you can do as well. So yeah, first we'll release a TensorFlow pipeline for the images around the field. You can see the images here, and they'll also release a pipeline for if you want to detect where the duck itself. But like I said, not a lot of teams use TensorFlow as they use the OpenCV as it's more powerful and you can get faster robots.
Est-ce qu'il y a d'autres questions? Well, thank you, James. Merci tout le monde. J'espère que c'était utile pour vous. Si vous avez des questions, quelque chose, vous pouvez m'appeler. Je peux communiquer avec James ou on peut se communiquer en trio, quelque chose. Merci beaucoup.
James. Thank you, everyone. Remember, if you have any ever questions, we are always here to answer any questions you have. Should it be programming, building a robot, anything.